Hi there. We continue today with polynomials. We're taking more questions on polynomials. Now let's go straight to it. Let's go straight to that. Now polynomials. I'm taking question 21 as here. Our first example is question 21. The polynomial f of x equals x cubed minus x squared minus 6kx plus 4k squared, where k is a constant, has x minus 3 as a factor. That means when it is divided by x minus 3, the remainder is 0. Question A, find the possible values of k. And B, find the integral value of k. For the integral value of k, find the remainder when f of x is divided by x plus 2. An integral value is a value which is a whole number, whether positive or negative. An integer is a positive or a negative whole number. So now f of x, I'm doing the first one, A. F of x equals x cubed minus x squared minus 6kx plus 4k squared. If f of x is divided, if x minus 3 is a factor of f of x, then the remainder, which is f of 3, by the remainder theorem, the remainder when f of x is divided by x minus 3 is f of 3. And it's given by 3 cubed minus 3 squared minus 6k times 3 plus 4k squared is equal to 0. Since x minus 3 is a factor, the remainder when it's divided by x minus 3 is going to be 0. And we know that remainder is the same as f of 3. So that means f of 3 is equal to 0. And that means 27 minus 9, which is... That means 27 minus 9 minus 18k plus 4k squared equals 0. And that means 18 minus 18k plus 4k squared equals 0. If we divide through by 2, we're going to have 2k squared minus 9k plus 9 equals 0. Now we can solve this by factorization. Solve this equation by factorization. Now let's go. That means 2k squared minus 6k minus 3k plus 9 equals 0. Which means 2k into k minus 3 minus 3 into k minus 3 equals 0. And that means 2k minus 3 times k minus 3 equals 0. So this simply means 2k minus 3 equals 0, or k minus 3 equals 0. Therefore, k equals 3 over 2, or k equals 3. So the integral value of k is 3, because 3 over 2 is not a whole number. The integral value of k is 3, because it's the one that is the whole number, which is 3. So that means k equals, those are the values of k. Therefore, k equals 3 over 2, or k equals 3. Now B, question B says, for the integral value of k, find the remainder when f of x is divided by x plus 2. So f of x when k equals 3, f of x will be equal to x cubed. We are substituting 3 for k in f of x, minus x squared minus 6kx. K is 3. That's minus 6 times 3 times x plus 4 times 3 squared. And that's going to be equal to x cubed minus x squared minus 18x plus 36. That's f of x. Now, they said we should divide it by x plus 2. We can use the remainder theorem too to do that, to find the remainder when f of x divided by x plus 2. So I can say when f of x is divided by x plus 2, the remainder let r, I think it's better put that way, let r be the remainder. Let r be the remainder. Let r be the remainder when f of x is divided by x plus 2. That means r equals therefore r equals f of minus 2. Of course, you know that the remainder when f of x divided by x plus 2 is f of minus 2 by the remainder theorem, which is, now you put minus 2 wherever you see x in f of x. That's minus 2 cubed minus 2 squared minus 18 times minus 2 plus 36, which is equal to minus 8 minus 4. You can see that this alone, minus 2 squared, is 4. And when you multiply that by minus 1, it becomes minus 4. So you have to be careful not to make mistakes there. Plus 36 minus 18 times minus 2 is plus 36 plus 36. And that's minus 8 minus 4 is minus 12. Minus 8 minus 4 is minus 12. Minus 12 plus 36 is 24. And that plus 36 is 60. And that's what's going to be. We check that more carefully. Minus 8 minus 8 minus 4 plus 36 plus 36, and that's 60. So therefore, the remainder when f of x is divided by x plus 2 is 60. The remainder when f of x is divided by x plus 2 is 60. Now let's take another question, another very simple one. Let's take question 22. Now 22. This says if f of x equals, if x squared plus 2x minus 3 is a factor of the polynomial f of x equals 2x cubed plus ax squared plus ax minus b, where a and b are constants, find the values of the constants a and b. Hence, question B, hence factorize Roman figure 1, factorize f of x completely. Roman figure 2, state the zeros of f of x. And Roman figure 3, find the remainder when f of x divided by x minus 5. All right, so let's get to it. 22a, f of x is a polynomial, and it is f of x equals 2x cubed plus ax squared plus ax minus b, where a and b are constants. Find the values of a and b. All right. And we are told that x squared plus 2x minus 3 is a factor. All right. I can split x squared plus 2x minus 3 into two factors. Yeah, into a product of two factors. And that's going to be x squared plus 3x minus x minus 3. And that means x into x plus 3 minus 1 into x plus 3, which means x minus 1 times x plus 3. So that means if x squared plus 2x minus 3 is a factor of f of x, that simply means x minus 1 and x plus 3 are also factors of f of x, because when you multiply these two, you are going to get x squared plus 2x minus 3. So the factors of a factor are also factors of whatever that thing is a factor of. So that's simple. If x squared plus 2x minus 3 is a factor of f of x, and x squared plus 2x minus 3 is the same as x minus 1 times x plus 3, that means the factors of x squared plus 2x minus 3, which are x minus 1 and x plus 3, are also factors of f of x. So I can say when f of x is divided by x minus 1, the remainder, which is f of 1 by the remainder theorem, is the same as 2 times 1 cubed plus a times 1 squared. Oh, sorry about that. That should not be 2a's. It is... okay, yeah, that's it. Plus ax minus b, that's correct. Plus a times 1 squared plus a times 1 minus b equals 0. Don't forget that x minus 1 is a factor, so the remainder will be 0, which is the same as f of 1. And that means 2 plus a minus b equals 0. And it means 2 plus 2a minus b equals 0. And that means 2a minus b equals minus 2. Let's call that equation 1. And now, when f of x, and the next, when f of x is divided by x plus 3, which is the second factor of x squared plus 2x minus 3, is divided by x plus 3, the remainder, which is f of minus 3, is given by 2 times minus 3 cubed plus a times minus 3 squared plus a times minus 3 minus b, and it is 0, because x plus 3 is a factor of f of x. Now that implies that minus 3 cubed is minus 27 times 2, that's minus 54. Minus 3 squared is 9 times a, that's plus 9a. Minus 3 times a is minus 3a minus b equals 0. And that simply means minus 54. That simply means minus 64 plus 6a minus b equals 0, which means 6a minus b equals 54. Taking minus 54 to the right hand side. That's equation 2. Now we can solve the two equations simultaneously. Solving 1 and 2 simultaneously. Solving equations 1 and 2 simultaneously. Equation 1 is 2a minus b equals minus 2. And equation 2 is 6a minus b equals 54. And we go that way. Okay. What do I do? Oh, I can eliminate I can eliminate b first by adding the second equation to the first. 2a plus 6a is 8a. No, not by subtracting. I'm supposed to subtract to eliminate. 2a minus 6a is minus 4a, and minus b minus b is 0. So that means minus 4a equals minus 2 minus 54 is minus 56. And divide both sides by minus 4 to get a. That means a equals 14. Now putting a in equation 1, that means 2a, which will be 2 times 14, minus b equals minus 2. And that means 28 minus b equals minus 2, which means b equals 28, or maybe we should go this way. Minus b equals minus 2 minus 28. And that means minus b equals minus 30. And it means b is equal to 30. So therefore, a equals 14 and b equals 30. That's it. Very, very simply. So that answers question A. And now to question B. It says factorize f of x completely. F of x is a cubic polynomial. It's a polynomial of degree 3. So it's supposed to have 3 factors. We already know 2 of them. So we can divide it by... We already know 2 of them, x minus 1 and x plus 3, whose product is x squared plus 2x minus 3. So we can divide it by that product to get the third factor, the remaining factor. So f of x will now be... f of x is now 2x cubed. We are replacing this. Let me bring f of x down, and you see how we substitute the values of a and b into it. This is f of x. That's f of x. So that's f of x. And I'm writing 14 wherever I see a and 30 wherever I see b. That means f of x equals 2x cubed plus 14x squared plus 14x minus 30. That's f of x. Now to factorize it completely, I need to find the third factor. And I'm going to do that by dividing it by the factor of it that was given. So that's x squared. I'm dividing f of x, which is 2x cubed plus 14x squared plus 14x minus 30 by x squared plus 2x minus 3. I know that x squared plus 2x minus 3 is the same as x minus 1 times x plus 3. But instead of dividing the polynomial f of x by either of these two, it's better to divide it by their product. That will just give you the third factor immediately. So that's what to do, since you already know that their product is a factor of f of x. Now there we go as usual. 2x squared divided by 2x cubed divided by x squared is 2x. Now when you get an answer, you multiply the whole of the divisor by that answer that you have got. So I'm doing... So now the next thing is multiplying everything, the whole of the divisor by the result. So x squared times 2x, that will be 2x cubed. 2x times 2x, that's 4x squared, minus 3 times 2x is minus 6x. And there you go. You subtract now. 2x cubed minus 2x cubed is 0. 14x squared minus 4x squared is 10x squared. And 14x minus 6x, that's actually 14x minus 6x, and it becomes 14x plus 6x, which is 20x. So 14x minus 6x is 20x. And when you're done with the subtraction, you bring that down the next term, which is minus 30. And we go again. 10x squared divided by x squared, that's 10. And then you multiply the whole of the divisor by that result. And there you go. X squared times 10 is 10x squared. Mind you, it's a factor, so the remainder is supposed to be 0. 10x squared. 2x times 10 is 20x. And minus 3 times 10 is minus 30. And you can already see that that's going to lead to 0. So when we subtract, what we have, 10x squared plus 20x minus 30 minus 10x squared plus 20x minus 30 is 0. So the remainder is 0, obviously. So that means the third factor is 2x plus 10. So I can say f of x is equal to x squared plus 2x minus 3 times 2x plus 10. But I know that x squared plus 2x minus 3 is the same as, is the product of x minus 1 and x plus 3. So that's what I write. So f of x is x minus 1 times x plus 3 times 2x plus 10. Those are the three factors of f of x, and that factorizes f of x completely. And so, okay. Any other? Oh, that's Roman figure 1 of B. That's actually B Roman figure 1. Now I go to Roman figure 2, which says, Roman figure 2 says, state the zeros of f of x. For the zeros of f of x, just make f of x 0. Let f of x be equal to 0. That means x minus 1 times x plus 3 times 2x plus 10 equals 0, which means x minus 1 equals 0, or x plus 3 equals 0, or 2x plus 10 equals 0. And therefore x equals 1, or x equals minus 3, or x equals, of course, minus 5. If you do that, 2x plus 10 equals 0. That means 2x equals minus 10. And divide both sides by 2. X equals minus 5. That's it, very simply. And therefore, the zeros of f of x are 1 minus 3, and minus 5. 1 minus 3 and minus 5. All right, that's it. Very, very simple. I think that was quite interesting. And now we take just one more question. Let's take just one more. And I'm taking number 24. And let's see, I'm taking number 24 as the next. 24. If x minus 1 is a factor of the polynomial f of x equals 4x cubed minus 4x squared minus x minus k, where k is a constant, find the value of k. Roman figure 1, find the value of k. Roman figure 2, factorize f of x completely and state its zeros. And Roman figure 3, find the remainder when f of x is divided by x minus 3. Oh, I didn't even finish question 22. There's a Roman figure 3 for 22. Sorry about that. Roman figure 3 says, find the remainder when f of x divided by x minus 5. So I should just say, when f of x, let r be the remainder. Let r be the remainder when f of x is divided by x minus 5. That means r is equal to r is going to be f of 5 by the remainder theorem, and that's given by, we know what f of x is. F of x is what's f of x? We already wrote that 2x cubed. This is f of x. Let me write that. Let me copy that. This is f of x. This is f of x. So that means f of 5 is 2 times 5 cubed plus 14 times 5. Just put 5 wherever you see x in f of x. Plus 14 times 5. 2 times 5 cubed plus 14 times 5 squared plus 14 times 5 minus 30. And that's equal to 5 cubed is 125 times 2 is 250 plus 5 squared is 25 times 14. 25 times 14 is what? That's 350 plus 14 times 5, which is 70, minus 30. Let's check that and be sure. 5 cubed is 125 times 2, 250. 14 times 25 is 350. And 14 times 5 is 70, obviously. So that's 250 plus 350 plus 70 minus 30. 250 plus 350 plus 70 minus 30. And that's 640. 5 cubed, 125, 250, 25 times 14. Checking to be very sure. And that's 70. 250 plus 350 plus 70 minus 30. That's 640. So the remainder when f of x divided by f of x is 640. So I say therefore r equals 640. Now to another one. We now go to what I wanted to do. Yes. Now, if x minus 1, we are taking number 24 next. If x minus 1 is a factor of the polynomial f of x equals 4x cubed minus 4x squared minus x minus k, where k is a constant. Find the value of k, Roman figure 1. Roman figure 2, factorize f of x completely and state its zeros. Roman figure 3, find the remainder when f of x is divided by x minus 3. So let's go to A to start with. F of x equals 4x cubed minus 4x squared minus x minus k. Now, if x minus 1 is a factor of it, if x minus 1 is a factor of f of x, then the remainder, which is f of 1, is given by 4 times 1 cubed minus 4 times 1 squared minus 1 minus k, and it is 0. Of course, the remainder is 0 if x minus 1 is a factor. And by the remainder theorem, that remainder is f of 1. So that means 4 minus 4 minus 1 minus k equals 0. 4 minus 4 is 0. 0 minus 1 is minus 1. Minus 1 minus k equals 0. and that simply means k equals minus 1. That solves that. That means k is minus 1. And now, Roman figure 2, what does that say? Okay, that's the value of k. That's actually 28, 24a, Roman figure 1. Now, Roman figure 2. Roman figure 2 says, factorize f of x completely. Now that we know the value of k, we can write out f of x completely. F of x will be 4x cubed minus 4x squared minus x minus 1, because k is minus 1. And that's 4x cubed minus 4x squared minus x plus 1. That's what f of x is actually. Now, how do we factorize that? We can factorize by division. Let's divide f of x by one of its factors. The factor of it that we already know, which is x minus 1. So I'm dividing f of x, 4x cubed minus 4x squared minus x plus 1 divided by x plus 1. I'm doing this to get the remaining factors of f of x. So we go as usual. 4x cubed divided by x is 4x squared. And when you divide, you multiply the whole of the divisor by that result. And that means x times 4x squared, that's 4x cubed, minus 1 times 4x squared, minus 4x squared. You subtract as usual. 4x cubed minus, oh sorry, this is supposed to be 4x cubed. Sorry about that. 4x cubed minus 4x cubed is 0. Minus 4x squared minus 4x squared, that's also 0. And now we bring down minus x, which is the next term. Now, minus x divided by, we go again, minus x divided by x, that's minus 1. And after that, we multiply that result by the whole of the divisor. So we are doing x times, that means x times minus 1. X times minus 1 is minus x. Okay. Well, since there was no x squared x term here, I could have brought this as 0x. So this will be, oh, hold on a sec. I want to repeat that. Sorry about that. Divide f of x by x minus 1. F of x is 4x cubed minus 4x squared minus x plus 1 divided by x minus 1. So 4x cubed divided by x is 4x squared. When you get an answer, you must multiply the whole of the divisor by that answer. So that means x times 4x squared is 4x cubed. Minus 1 times 4x squared is minus 4x squared. Now we subtract. There's no x term here, so let me write 0x. So we subtract, and then we have 4x cubed minus 4x cubed is 0. Minus 4x squared minus 4x squared is also 0. Minus x minus 0x is minus x. And then you bring down plus 1. So now the next thing is, we divide minus x by x. Minus x divided by x is minus 1. And we go again the usual way. Multiply this result, the whole of the divisor by that result. So we are doing x times minus 1, which is minus x, and minus 1 times minus 1, which is plus 1. I hope that's clear. We are multiplying this by minus 1 and minus 1 also by minus 1. So that means minus x plus 1. Now we subtract as usual. When we subtract, this will give us 0. So of course, that's what it's supposed to be, because x minus 1 is a factor of f of x. So that means f of x is equal to x minus 1 times 4x squared minus 1. But we can factorize 4x squared. We can split 4x squared minus 1 into 2 factors, which will be, this is actually a difference of 2 squares. So I can write it as 2x all squared minus 1 squared. And that's 2x plus 1. That's what difference of 2 squares factorizes into, times 2x minus 1. Therefore, f of x is equal to x. Always note that the degree of a polynomial gives the number of roots or factors it should have. A cubic polynomial must have 2 roots and 2 factors. A polynomial of degree 2 must have 2 roots and 2 factors. Of degree 4 must have 4 roots and 4 factors. So that's why our factors here are 3 for f of x. And that's it, very, very simply. That factorizes f of x completely. Now to Roman figure 3. Roman figure 3 says, okay, factorize f of x completely and state it 0. To state the zeros of f of x, let f of x be equal to 0. That means x minus 1 times 2x plus 1 times 2x minus 1 equals 0. Which means x equals, therefore, x equals 1 or x equals minus 1 over 2. Of course, you know what I'm doing. Or x equals 1 over 2. And that means the zeros of f of x are 1 minus 1 over 2 and 1 over 2. Those are the zeros of f of x simply. So we go to Roman figure 3. It says find the remainder. Find the remainder when f of x is divided by x minus 3. Let r be the remainder. Let r be the remainder when f of x is divided by x minus 3. That means r is equal to, when you divide f of x by x minus 3, by the remainder theorem, the remainder is f of 3. And that's equal to, what is f of x? I think I still have that. No, this is not f of x. I think I need to copy that. F of x. What's f of x here? This is f of x. This is f of x. Copying that here. This is f of x. So that means f of 3 is 4 times 3 cubed minus 4 times 3 squared minus 3 plus 1. That means wherever you see x in f of x, you put 3. 4 times 3 cubed minus 4 times 3 squared minus 3 plus 1. And that's 3 cubed is 27 times 4. 27 times 4 is 108 minus 3 squared is 9 times 4, 36 minus 3 plus 1. So that's 108 minus 36 minus 3 plus 1, which is 70. So that's the remainder when f of x is divided by x minus 3. And that's it, very simply. Let's go to question B. Question B is actually another, actually has another polynomial. Now B, if the polynomial f of p of x equals 3x squared plus 4x plus 5, write P of x okay, I think we should stop there, and we might take that. You might have that as an exercise to attempt yourself. So that's it, very, very simply, and it's quite interesting. I'm going to give you the second part of the last example as an exercise to do yourself. But for now, I think for now, go through the whole of the explanations, and I'm sure you understand it. Thank you very much, and see you in the next. Bye bye.